You're cramming for finals at 2 a.m. Running on fumes, you open an app to order a Red Bull and a bag of chips. Within seconds, your order is routed to a neighborhood warehouse where a picker bags the items and hands them to a waiting rider. 9 minutes later, the rider is at your door. This speed feels like a glitch in the simulation, as if the snacks materialized the moment you hit confirm. There is zero magic involved. This is the result of very fast, very expensive, and very brutal math. This system relies on geospatial analytics, microservices architecture, and artificial intelligence. Geospatial analytics is the processing of location-based data to optimize physical routing and distribution in real time. To understand how companies like Septo or Blinkit achieve this, we have to tear down the entire supply chain, from the layout of their hidden dark stores to the algorithms predicting your cravings before you even open the app. The convenience of a 10-minute delivery is the visible output of a complex physical infrastructure and a specific financial strategy. If your warehouse is a 1,000,000-square-foot facility on the outskirts of the city, you cannot deliver in 10 minutes. The distance to the customer is a physical barrier that speed cannot overcome. The solution is the dark store, a hyper-local micro-fulfillment center planted inside a dense residential neighborhood. These spaces are strictly closed to the public and typically range from 2,500 to 4,000 square feet. They are designed for one purpose: extreme proximity to your front door. While a traditional grocery store might stock 50,000 items, quick commerce platforms curate a selection of 2,000 to 5,000 high-velocity SKUs. This isometric diagram shows the interior layout, dictated by an algorithm. High-velocity items like milk are placed right next to packing stations to minimize travel time. The floor plan is optimized so a picker never walks more than 30 feet for a popular item. A dark store prioritizes algorithmic proximity over retail aesthetics. It is a warehouse disguised as a neighbor. To maintain this speed, the platform must anticipate demand before the order is placed. This is achieved through predictive AI. Demand forecasting uses models like LSTM, a neural network for sequential pattern recognition, and ARIMA, a statistical model for future trends. They ingest historical purchases, weather, university schedules, and traffic flow to position inventory perfectly. When you finally open the app and tap Pay, the system shifts from prediction to perception. The app employs a strategy called optimistic UI. Optimistic UI is a design approach where the interface responds as if an action is successful before the server provides a final confirmation. You see an instant order confirmation screen while the backend is still quietly processing your credit card via an API. In this business, a 1-second loading screen is a failure. Masking that digital latency is as critical as the physical delivery itself. Once verified, your order hits an asynchronous message queue like Apache Kafka. Kafka is a distributed stream processing platform that handles massive real-time data without crashing. It instantly routes your order to a picker's handheld terminal inside the dark store. The physical math for a 5-item order is precise. Fulfilling the order requires walking approximately 250 feet. Walking at 5 feet per second takes 50 seconds. Scanning each item takes 10 seconds. That leaves the physical picking time at exactly 100 seconds. With 20 seconds allocated for bagging, the order is ready for the rider in exactly 2 minutes. Software generates a Z-path for the picker. A Z-path is a routing method that moves staff through aisles in a continuous, uncrossing line to eliminate backtracking. Stores often use pick-to-light technology, where LED strips beneath the items illuminate to show the picker exactly what to grab. Inside the store, human labor is directed by the algorithm to ensure the precision of a machine. Once the order leaves the store, the focus shifts to chaos control on the street. Rider assignment solves a bipartite matching problem, an optimization challenge used to pair riders and orders for maximum efficiency. The AI calculates the rider's heading, proximity, and available bag space to see if multiple orders can be batched. The rider's route is optimized by engines like OSRM. OSRM, or Open Source Routing Machine, is a high-performance engine that calculates the shortest paths through road networks by factoring in live traffic and closures. But the rider eventually hits a constraint the algorithm cannot bypass: the high-rise elevator. A rider can beat traffic in 6 minutes, only to spend 7 minutes waiting for an elevator in an apartment building. This vertical logistics issue, combined with safety concerns for the riders, has led many platforms to move away from absolute 10-minute guarantees. Perfect digital routing eventually bottlenecks against the vertical physics of the city. The logistics are impressive, but the financial viability of this model is a different matter. On a $15 order, the platform's gross margin is about 20%, or $3. This $3 margin is quickly consumed by rider pay, dark store rent, inventory wastage, and promotional coupons. In many cases, these platforms take a contribution loss on small, late-night orders. Currently, the 10-minute delivery is a strategy used to capture market share, rather than a naturally profitable transaction. How do loss-making platforms justify multi-billion-dollar valuations? The first path to profitability is increasing the average order value. The app uses AI to nudge you toward high-margin items, like electronics or premium personal care products, to flip the transaction from a loss to a profit. The second path is turning the app itself into an advertising network. Brands pay a premium for top-shelf placement. When you see a bestseller list, you are often looking at paid advertising real estate, rather than an organic ranking. When you order that midnight snack, you are a data point in a massive network of inventory caching and geospatial routing. For more deep dives into e-commerce logistics frameworks, hit subscribe. Behind the simple tap of a screen lies a network of inventory caching, geospatial routing, and venture-backed financial strategy.